Today we're going to show you a method for testing the delay of writing on a touchscreen. So when you write on a touchscreen, there's a certain amount of delay, and you want to be able to write smoothly so that what you see on the display is what you write without any delay between what you write and what is seen on the screen. We will show you a method for testing the writing delay of touchscreen displays. This can be used as a standard to compare display combinations with each other. This is not an absolute measurements of each of the component. It doesn't measure the display delay or the touch delay or the software delay. It measures all three together to use for comparison with other displays. This method doesn't allow you to measure the individual component delays. The measurement is the total delay of the whole system from the time that you start writing till the time something appears on the screen.
What you'll need to perform this test is a display with a USB touch interface, a PC running Windows, because we're going to be using the MS Paint application, and an iPhone or an Android or a tablet or a camera that's capable of shooting 240 frames per second. And finally, you'll probably want to use a Post-it note or some sticky tape. So there are 3 steps to this. The first step is setting up the equipment. The second step will be recording the writing on the display. And then the final step will consist of measuring the latency of the display. The first thing you'll want to do is hook up the display to the computer either using DVI or HDMI. Then you'll want to hook up USB from the display to the computer. That way the display will act like a mouse input to the computer. Next, you'll want to launch MS Paint. The reason we use MS Paint is because it's an application that comes on just about every Windows computer, so it's an easy software package to access. And finally, you'll want to set up your camera to make sure it's recording at 240 frames per second. When you hook up the touchscreen to your laptop, you may have to install on your computer a touchscreen driver. First, I'm going to connect the display to my laptop. First, I'll hook up the USB input, and then I'll hook up the HDMI into my computer. My computer has a display port, so I'm actually using a display port to HDMI converter. Next, you'll want to launch MS Paint. You can go down here to the Windows icon, go into All Programs, go under Accessories, and then find Paint. To set up your iPhone to record at 240 frames per second, go into Settings. In the Settings, then scroll down to the Photo Camera Settings. Inside here, you'll want to scroll down to where you see Record Slow-Mo. Under there, you'll want to make sure that 720p HD at 240 FPS is selected. The next step is to record. What you'll want to do is you'll want to make sure that your iPhone or whatever your device you're recording with is set to slow-mo. Then you'll want to point it and make sure you can get the screen in the field of view. In MS Paint, you'll want to then draw several lines very quickly. You'll probably want to go from right to left, and the reason is that way you'll be able to measure the distance between your finger and the line that's drawn. Okay, Alan, you ready? I'm going to start recording, and you can draw in 3, 2, 1. Next, you'll want to measure the results. For this, I use iMovie on my iPad. And what I'll do is I'll mark a point in the video where I actually see the line being drawn. And that's where that sticky tape comes. I'll then put a Post-it note or that piece of sticky tape right where the line is. Then I'll step backwards one frame at a time until I actually see my finger meet up with the line that was drawn. After I do that, I'll count those number of frames. However many frames I get, I'll then multiply by 4.16. The resulting number is the total latency of the touch input, the screen display, and the drawing software. Next, I'm going to take the video clip we shot and I'm going to import it into my iPad. On my iPad, I'm going to use iMovie for measuring. iMovie lets me get down to the frame. So here's the video clip we shot, and I'm actually going to zoom in real close on it. Now, if you look up here, I can see in slow motion Alan drawing the line. But you can also see there's a gap between where the line appears and where Alan's touching. That's the latency we're going to measure. So I'm going to find a spot where the line just starts to appear, right about there. And remember I told you get a sticky note or something? So I'm going to paste that right over the line. And now I'm going to step backwards one frame at a time until Alan's finger meets up with the line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, maybe 18. Between 17 and 18 frames. So now what I'll do is I'll take that number and I'll bring it into my calculator. And in my calculator, I'm going to calculate 4.16, that's what we said, times 17 frames. And that gives me 70.72 milliseconds.
Why multiply by 4.16? That's a good question. At 240 frames per second, each frame is 4.1 milliseconds. So if you divide 1 divided by 240, you get 4.16. So as we're counting the frames, each of the steps that Stephen has taken is 4.1 milliseconds. We multiply that by the number of steps, and that gives you the total delay of the whole system. With a little practice, you can do this in about 30 minutes or less to test different monitors and touch combinations. Now you can certainly use other methods with other cameras or other methodology, but the key here is to use one standard on all the displays that you're testing, one standard method where you can do a comparison. Using this method, we recommend a total delay of the display, the touch surface, and the application, which is MS Paint, together about 70 milliseconds. If you go with 70 milliseconds, you're going to have a relatively fast writing response.